Hello and welcome to Module 2. Now in the last lesson in Module 1, we learned how to play 3D events in a 3D space within our game, so that the location of them can be heard by our player. In this lesson, we're going to look at how we can simplify the process for sounds we only need to play once, by learning about FMOD's play one shot command. First, let's start by learning how they work. So a play one shot allows us to play one of our FMOD events anywhere in our game by writing only one line of code. In this line, FMOD will know to play the event as soon as it's been called and stop the event automatically once there is no more audio left on the event's timeline, saving us from doing it in our code. It also creates a temporary event instance by itself without the need to store it in a variable. The instance even destroys itself once the event has stopped, meaning we don't need to call the release command. Now this is a fantastic tool for short sound effects that only need to be heard once, saving us a lot of time. So to demonstrate this command, we're going to be implementing a sound to play when our player picks up their melee weapon. Like last time, we'll start by creating a simple event to play our sound and assigning it to our master bank. So the first thing we're going to do is create a new folder. We're going to call this folder Interactables, and we're going to place this folder inside of the sound effects folder. Then inside it, we'll create a new 3D event. We'll call it Staff Collect, and then inside our audio bin, we will look inside the Interactables folder. We'll go to the switches folder and we will use the switch activated 01 file at the beginning of the timeline. Then once we've done that, let's right click the event and assign it to the master bank. Then let's save our project, build our banks, and jump back into Unity to see how we can implement it. So the way we're going to play our sound is by using what's called a trigger. Now triggers are designated spaces in Unity which, when interacted with by our player or any other designated game object, can provide certain behaviors that we tell it to. To create a trigger, we need to attach a collider component to a game object we want to use as our trigger. Now if we click on the level 01 gameplay object and open it up, double-click the weapon pedestal to be taken over to it in the Scene tab. Then take a look at the child objects of the weapon pedestal. We can see one called Staff Take Trigger. Now if we have a look at it in the Inspector tab, we can see that this object has a sphere collider component already attached. Normally this component determines the shape and size of a game object's collision area. If another game object tried to pass through this area, it would not be able to pass through and would collide with it instead. Collision detection is what is used in game design to prevent objects from passing through each other unnecessarily. For example, both our player and the ground they walk on have colliders attached to them to prevent the player from falling through the floor. Now as you can see in the Scene tab, this sphere represents our collision area for this object. However, if we take a look at it again in the Inspector tab, we can see a box labelled Is Trigger is ticked. Now this means that the area will no longer collide with other objects, but instead can be used to tell if something has passed through it. This is how the player is able to pick up the staff itself. When they pass through the area, the game can detect this and provide them with a new weapon in response. We'll use this to play our Staff Collect event we created in FMOD when this happens. So let's once again make our way to the FMOD folder so that we can create a new script. So I'm going to create it and call mine F_staff collect trigger. Once we've then created the script and it's finished compiling, we can drag it onto our game object to add it, and then we can open it up to edit it. First thing we're going to do is delete both the start and the update function, as we won't be needing them for what we're doing today. To check to see if anything has entered our trigger area, we have 3 new functions to choose from. First looks like this, and it's called on trigger enter. Now this function will perform whatever we tell it to on the exact frame a new object first enters our area. On trigger exit works the same way, but instead runs on the final frame an object leaves our area. And the final one is on trigger stay, which will run on every frame whilst an object is inside our area. All are very easy to use and very helpful, but we'll be needing on trigger enter to play our event as the player collects the weapon. So let's change the word stay to the word enter. Now inside this function, it's time to create our play one shot command. To create it, we're going to write fmod unity.runtimemanager.play one shot and add 2 empty brackets. Inside the brackets, there's 2 arguments we need to fill. Now the first thing we need to give our one shot is our event path or our event GUID. So let's quickly write that in now. Now the second is the location in our game world of where we want this sound to be played. Now in the last lesson we gave our commands the location of our game object in the form of a reference to the transform component attached to the same object. And whilst we'll still be doing that in a way, our play one-shot command will only accept it in the form of a certain data type that we haven't yet looked at. This is the vector data type. Now, if you happen to have studied maths at a more advanced level, you may be familiar with vectors already. If you haven't, then you can think of vectors as a combination of numbers that, when plotted onto a 2D or 3D graph, and compared to a point of origin, provide both a magnitude, otherwise known as a distance, and a direction between the point of origin and itself. In Unity, they're used in similar ways. We can use them to set new positions for our game object, or move them in a specific direction. For our play one-shot command, we just need to give it a position, so we'll create a variable using the vector data type to store that position inside of. Now there are two different types we can use. The first is called vector2. Now inside a vector2 variable, we can store values for the x and y coordinates in our game. This is a popular choice when using vectors in a 2D game, as you only use the x and the y axis most of the time. Vector3, on the other hand, uses the x, y and z coordinates, meaning it's the better choice for us and our 3D game that uses all three axes. Both vector2 and 3 take multiple float values, as the values can be numbers with decimal places in them. So if we were to create a variable of either of these two types, we need to call its data type, which we've done, and then give it a name. So since we're after the position of the staff take trigger object, a nice name for our variable might be pos, short for position. Now to store values, or rather a set of coordinates inside a vector variable, we need to write the word new, followed by its data type, and two brackets. Inside these brackets is where we give our coordinates. The first value we give is the x coordinate. So for example, I'm going to write 5.2 as the x value. Now notice how I've added the letter f next to my value. Remember, this is because we're using numbers with decimal places. So just like we would for a float variable, we need to add a letter f next to our values. Next, we're going to separate this with a comma and add a number for the y coordinate and do the same again for the z coordinate. And now we have a vector variable containing a specific position in our game world. Now, if we wanted to, we could go into Unity, select our staff take trigger object, and manually copy the positional coordinates from the transform component in the inspector tab into our pos variable. But as we established in the last video, we can actually reference our transform component directly in our code, which will update these coordinates automatically should the object move and change them. Now, whenever we want to store information inside a vector variable, we have to do it inside a function. Let's first remove those coordinates we stored inside the pos variable, and inside our onTrigger enter function, we'll set new values for the pos variable by referencing our transform component by writing get component transform, just like we did in the last lesson. Now on its own, this is going to give us an error indicated by the red squiggly line underneath it, and won't actually work if we save our script and try it in Unity. The reason why is because we can only store vector information inside vector variables, just like how we can only store integers inside int variables and floats inside float variables. Remember, transform is a reference data type used for referring your code to a specific transform component. Therefore, we can't store a reference of this component inside the variable of the vector3 data type. What we can do, however, is extend our code to refer specifically to the position part of our transform component, which is in vector data. If we go back into Unity and look at our transform component again, we know it contains information for the game object's position, rotation, and scale. All three of these are vectors, as they each contain three values, one for the x, y, and z coordinates. So in our script, if we refer to one of these three vectors specifically, we can store them inside our position variable. So let's go back, and following where we wrote get component transform, we can choose one of those vectors by following it with the dot operator, and then writing the name of one of them. So for example, position. We can then add this to the play one shot command and we're good to go. Now, before we test to see if our code works, we must make sure a few conditions have been met. As we learned earlier, for a trigger area to work, it must contain a collider component with the is trigger box marked. As well as this, however, the object entering the trigger area must meet either one of two particular conditions. The first is that the object entering the area must have an attached rigid body component, otherwise the trigger area will not recognize it when the object enters. In our case, if we select the object our player will be controlling, which is the Ellen game object, if we scroll down the inspector tab of this object, we can see it does not have a rigid body component attached to it. This means that for our onTriggerEnter function we wrote in our code to work, we need to make sure another condition is met by the Ellen game object. We take a look under the game object's name in the inspector tab. We have options to select a tag and a layer for this object. Now, tags are used as a way to label game objects, and layers are used to group them together and organize them, both of which help us organize and recognize these objects when interacting with them inside our code. We'll be looking more at tags a little bit later on in this course, but for now we're more interested in layers. So in Unity we can organize and group our objects together by opening the drop-down menu called Layers and selecting a layer. As you can see, we have many options to choose from for our Ellen game object, but seeing as this object is controlled by the player, it makes sense to leave the player layer selected. Now, if we go over to our Edit tab, choose Project Settings, and then select Tags and Layers, we can now open up a menu for controlling layers. Here we can delete layers and we can make our own if we wish to. If we then go to the Physics tab, we get another page that allows us to control the Unity engine's physics. Now, at the bottom is a tick box table called the Layer Collision Matrix. In this table, we can decide which game objects are able to collide with each other based on the layer that they have been assigned to. So, for example, we know the Ellen game object has been assigned to the player layer. So if we take a look at the player row, we can see all of the other layers that our player can collide with. Now, if we go along this row, we can see the box underneath the environment layer has been ticked. This means that any objects labelled under the player layer and any objects labelled under the environment layer can collide together. Now, if we were to untick this box and quickly play our scene, we'd notice something very odd happen. We can see that the player falls straight through the ground as soon as the game starts. Now, this is because the floor the player was standing on was registered to the environment layer, which are now completely incompatible layers. Now, as well as colliders, this also applies to trigger areas as well. So if we reselect the staff take trigger object, we can see that its layer is environment. Therefore, we'll want to make our way back to the layer collision matrix and reselect the player and the environment tick box, so that our onTriggerEnter function will play when our Ellen game object enters it. So now that we know that both the trigger box and player character are assigned to compatible layers, so the last thing we need to do is go back to our script and quickly double check that we saved it. And now if we go into Unity again, play our game, we'll be able to test to see if the play one shot command will run whenever we enter this area. So if I now jump inside of the trigger area, we hear our play one shot command run and we hear our event. Perfect. So as we've established, the play one shot command works by playing an FMOD event at a specific location in our game world via a vector. Now, in our case, we wanted that location to be where our staff take trigger object is. And whilst we were able to tell our command to play our event here, FMOD actually comes with another one-shot command designed specifically for playing events in the same location as game objects. So let's go back into our script. We're going to remove everything apart from our function, and we're going to talk about this new command. So as mentioned, the play one shot attached command works very similarly to a regular play one shot command. We can set it up in the same way by writing in our onTriggerEnter function fmod unity.runtimemanager.play one shot attached with two brackets. We'll then enter our event path again into the brackets as a string. Add a comma next to it, and instead of giving our command a vector, we need to give it a specific game object to play our event alongside of. So just like how in our last lesson, the attach instance to game object command would only accept the transform reference data type, our play one shot attach command will only accept the game object reference data type. Now in Unity, there are multiple ways of acquiring an instance of a game object in your code. You can search for the object or even multiple objects by searching for their name, their tag, certain components that might be attached to them, and even more. The easiest option for us is to simply write in our command game object with a lowercase g and an uppercase O. Now by writing game object specifically like this with the lowercase g, we're actually able to use it because our script derives information from mono behavior. It holds an instance of whatever game object the script we write it inside of is attached to. So now our command will know to play our FMOD event at our staff take trigger object. Let's quickly save our script, jump back into our game and test it one more time. And once again, we hear it perfectly. Now, if we wanted to, we could tell our script to play our event at the position of another game object by using the game object reference data type to create a variable that could store a reference to another object in our scene and use that inside of our play one shot command. However, it's not really necessary in our case as we've already got our event playing where we want it to. And Module 3 will be looking into how we can reference other game objects in our script to play audio from in more detail. So as you can see, the play one shot and play one shot attached commands are very powerful tools we can use to quickly play back our events. The main downside to them, however, is that we're unable to manipulate any FMOD parameters we might have designed for the events we're playing through them, which is something we'll be looking at in more detail in the next lesson. Great, so now we know the difference between how to use the play one shot and the play one shot attached commands. We've also touched a little bit on layers and their relationship with the Unity engine, as well as how we can set up and use trigger areas to trigger our audio. If you feel like you want to practice with what you just learned, see if you can set up some trigger areas of your own that play one shots for when the player enters a certain area. Then in the next lesson, we'll be taking a look at how we can interact with FMOD parameters. Thanks for watching this one, and I will see you in the next one.